Hello there, kids! Welcome to our first online lesson in science. Before we begin, I would like to give you a little information of what you see on the lower right corner of the screen. As you can see, we have Metanoia Learning Center G6.1.1 Mixtures and Solutions. The G6.1.1 actually means Grade 6, Chapter 1, Lesson 1, the topic to be discussed. This is for us to easily keep track of our lessons. Anyway, let us now start with our lesson. Our topic for today is about matter, mixtures, and solution. But before we advance to mixtures and solutions, let us do a recap about matter. What is matter? Matter is anything that has mass and has volume. Mass refers to the number of particles that the object is made of, while volume refers to the amount of space taken by an object. So basically, matter is anything that has mass and occupies space. We are made of matter. The object that you are using to watch this video is made of matter. Everything around us is made of matter. You should know that because that's part of your past lesson. Let us review about the basics of matter. This picture shows a basic diagram of matter, which consists of the topics that you have already learned and the topic for you to learn. To start off, we have the basic states of matter. The three basic states of matter are solid, liquid, and gas. And if you can remember our past lesson, we know that solid has definite shape and has definite volume, which means no matter what you're going to do with a solid, its shape will remain the same unless you're going to break it in half. And the volume of that solid will not change at all. For liquid, liquid has no definite shape but has definite volume. In other words, if you are going to transfer water from a certain container to a different type of container, especially with a different shape, basically, that liquid will take the space of the container and still has the same amount of volume. For gas, gas has no definite shape and has no definite volume, which means that you can never determine the amount of gas that you have in a certain container or in a certain area. For the behavior of the particles, for a solid, particles are tightly packed. For liquid, particles are a little loose compared to solids. And for gas, their particles are loose. So technically, the behavior of the particles of a matter determines which type of matter it is. This diagram shows us the processes involved on how states of matter change from one state to another. Let's take water as our example for liquid. Once the temperature is decreased, which means getting colder, water starts to freeze and turning water into solid ice. This process is called freezing. Reversing the process, once temperature is increased or getting warmer, the ice will start to melt, turning back the solid ice to liquid. And this process is called melting. And if the temperature will further increase, particles of water will start to move faster than usual, changing water to gas through the process of evaporation, where liquid is turned into gas. Once water turns into gas form or water vapor, and the temperature will start to decrease or getting colder, the vapor will slowly start to go back to tiny droplets, just like how clouds form and how you breathe to a glass surface during a cold weather. This process is called condensation, where gas turns into liquid. Solid to gas is called sublimation, where solid turns directly into gas, like dry ice and mothballs. Gas to solid is called desublimation or deposition, where extreme coldness causes water vapor to turn into solid ice. Temperature is the main reason for the change of state of matter. Another subtopic of matter is changes. The physical and chemical change. Physical change. The size or shape of matter may be changed but no chemical reaction occurs. For example, if you tear a piece of paper, the chemical composition of paper will remain the same. If you freeze water, the chemical composition of ice is still the same as water. Chemical change. A chemical change, also known as a chemical reaction, is a process where one or more substances are altered into one or more new and different substances. In other words, a chemical change is a chemical reaction involving rearrangement of atoms. Usually for a chemical change, the process is irreversible, which means we cannot undo the process. For example, if you burn a piece of paper, you cannot turn the ashes back to its original state. This basically means that the change is irreversible. Once you cook egg, you cannot turn it back to being raw. Once you burn paper and wood, they turn into ashes. Ashes cannot be turned back to paper nor wood again. It may be possible but still through chemical change. Unlike in physical change, objects may break into tiny pieces, the chemical components remain the same. Wood is still wood. Now you might ask, how about water changing to gas? Water may have changed into gas but the chemical composition is still the same. And take note, the process is reversible. Another subtopic of matter is purity. Under purity, we have pure substance and mixture. Pure substance are substances that are made up of only one kind of particle and has a fixed or constant structure. Under pure substances, we have elements and compounds. Elements are composed of only one atom, just like the periodic table of elements. Each element is composed of only one atom. As for compounds, a compound is a molecule made of atoms with different types of elements. All compounds are molecules, but not all molecules are compounds because some molecules are composed of more than one element of the same kind. For instance, all of these are molecules, as molecules consist of two or more of the same or different elements, while compounds should consist of two or more different elements. So let's have a recap of what we have talked about a while ago. The three basic states of matter: solid, liquid, and gas. Another type of matter is plasma. Plasma is not a common state of matter on Earth, but may be the most common state in the universe. Stars are superheated balls of plasma. Plasma consists of highly charged particles with extremely high kinetic energy. Neon light signages are made of gas, gases that are electronically ionized to reach the plasma state. BEC, Bose-Einstein condensates. BEC or BEC is a man-made state of matter. Lasers and magnets are used to cool a specific element to a point of where the molecular motion almost comes to a stop, almost to a point of absolute zero. At this point, atoms begin to clump together, forming one superatom. Properties of matter. Solid has definite shape, has definite volume. For liquid, has no definite shape but has definite volume. For gas, has no definite shape and has no definite volume. For changes, we have physical change, which means the size or shape may change but the composition of matter remains the same. No chemical reaction is involved. For chemical change, chemical reaction occurs and atoms are rearranged. And it is also an irreversible process. Purity or pure substance. Elements composed of one atom. Molecules composed of two or more of the same or different types of atoms. For compounds, composed of two or more different types of atoms. Allow me to go back to this illustration. As you can see, that these are sets of molecules. All that you see here on your screen are molecules, but not all of them are compounds. Some of them are compounds. If you remember, there's something that I mentioned that all compounds are molecules, but not all molecules are compounds. Why? As you can see, the definition for molecules is that it is composed of two or more of the same, such as you can see here, we have 2 units of hydrogen. This is composed of 2 or more units of the same. This is composed of 2 units of hydrogen, the same type of atom. 2 units of oxygen, the same type of atom. 2 units of nitrogen and 2 units of chlorine. It also says that molecules are composed of 2 or more different types of atoms, such as in this case, we have 2 different types of atoms combined. We have nitrogen and oxygen. Combined, we call it nitrogen oxide. Whereas for compounds, compounds are composed of 2 or more different types of atoms. That is the only difference between molecules and compounds. For molecules, it is possible for it to be composed of 2 of the same atoms. While for compounds, it should be 2 different types of atoms. 2 or more different types of atoms. What do you mean by mixtures? 2 or more substances that are physically combined, solid, liquid, gas, or a combination of the three. A mixture that can be physically separated means there is no chemical change. No new substance is formed. A mixture of solid and solid, such as gravel. A combination of fragments. Mixed nuts. Yum. A mixture of different types of peanuts and such. Another example of a mixture is liquid and liquid, such as oil and water. In this mixture, oil is less dense than water. This is why, over time, oil will rise up to the surface of the mixture. We also have ink and water. Another example is a mixture of gas and gas. Well, technically, around us, we have mixture of gases. We have oxygen, carbon dioxide, argon, nitrogen, and water vapor. Fumes and smoke are also considered as gas. Examples of solid and liquid mixture. We have salt or sugar solution. gravel, and pebbles in rivers, water, and ice cubes. For the salt or sugar solution, our salt or sugar is the solid, while the water is our liquid. For gravel and pebbles in rivers, obviously the gravel and pebbles are the solid, and the water in the river is the liquid. And of course, one of our favorite thing to drink when we are thirsty is ice cold water. Obviously, the water is our liquid and the ice cubes are the solid ones. We also have a mixture of solid and gas, such as dust particles and air. We also have the liquid and gas mixture, especially where gas is trapped within a liquid and escapes through bubbles like soda or any carbonated liquid. A combination of all three is also possible, and we love having this drink: soda and ice. No sugar for me. The soda alone is already composed of liquid and gas to trap carbon in the specific liquid. There are two basic types of mixtures, and these are the homogeneous mixture and the heterogeneous mixture. Homogeneous mixture is a uniform mixture. Its components cannot be easily distinguished by the naked eye. It is mixed all throughout. For a heterogeneous mixture, it is not a uniform mixture or non-uniform mixture. Components can be distinguished immediately. Now, what is the difference between a homogeneous mixture and a heterogeneous mixture? These are examples of a homogeneous mixture. As you can see, the components cannot be easily distinguished by the naked eye. As for a heterogeneous mixture, you can easily distinguish the components used to form the mixture. So that's basically it. That's the end of our first lesson for our first chapter in science.